So we've been talking about circles in our first little unit lesson, and we talked about this finding the center of a circle and the radius of circle when you're given the equation of a circle. And for that equation, it wasn't too difficult because that form is set up as this center radius form of a circle. So it's very easy to find that information. But what if it's not set up in that form? And that's where we have to go back and review a little bit of algebra so that we can do that and figure that out for geometry. So this lesson that we're doing today is going to be very algebra based and is going to sort of help us prepare for what we're going to do tomorrow in our next lesson, okay? So let's review some algebra. Let's go and take a look at some basic stuff, like a perfect square trinomial. What is a perfect square trinomial? Well, let's think about, first of all, squaring a binomial. So in this example here, we've got a binomial that is squared. So let's square that binomial. Go ahead and expand that and see what you get. Now, hopefully, as you were expanding that, you were able to realize that what you have to do is you might have to rewrite this as 5x minus 3 times 5x minus 3, okay? And then FOIL that out. So 25x minus 15x minus 15x plus 9. And then we combine the middle two terms. Whoops, I forgot a squared here. Plus 9. So there is our expanded version. And this is called a perfect square trinomial. The reason it's a perfect square trinomial, first of all, trinomial, 1, 2, 3 terms. Why it's a perfect square? Because the square root of this entire trinomial is this 5x minus 3. Okay, so we got this thing by squaring a binomial. That's what is considered a perfect square trinomial. So it's a trinomial found by squaring a binomial. And therefore, you could technically take the square root of a perfect square trinomial. So all perfect square trinomials are going to be in this form, a squared plus b squared, or a squared plus bx plus c, where b is very, very important. Because let's go back and look at what this thing comes out to be. The 25, I'm going to change colors here. This 25x squared. Well, that is this thing squared, right? So basically 5x squared gave me the 25x squared. And the 9 is basically the 3 squared. Okay, so this term, well, you could almost look at it as the square root of a plus or minus. Actually, I'm going to use minus here. The square root of b. When you square that, that gives me the first two terms of this. Well, let's not make that b. I didn't mean b there. I meant c. Sorry about that. Let's make that c. That gives us the first two terms of that figure. Oops, except it's not. Okay. And usually there's some sort of like x squared and a constant. And then there's something in the middle. Okay. So let's review that again because it was a little confusing the way I said it. When you take the first term of your binomial and square that, there's your a term or your a coefficient. Is that 5 squared is 25. The squaring of the second term in the binomial gives me the squared constant in the trinomial. So this b term is what's really interesting. The b term, notice what happens here. We took 5x times 3, 5x times 3. So basically you took the first and second term and multiplied them together. Okay, so that's the first thing that happened to get the b term. I took the first term, which was square root of a, and multiplied by square root of c. In this particular problem, the 30x equals, first of all, 5x and negative 3. Okay, so that's where that comes from. And remember, 5x is the square root of 25x squared. Negative 3 is the square root of the 9. So what happens there, though? This only gives me 15. So you have to multiply it by 2. So there's the b term. That's always going to be that middle term when it's looking at a perfect square trinomial. Not every trinomial, just a perfect square trinomial. We could simplify that by putting a and the c under a single square root. Okay, that we learned how to do in our radicals unit. But when we're doing this, if I'm going to factor something like this, I already know what those terms are. How do I get this C term? Well, actually, let's look at it this way. Let's say, make it a little easier. Instead of making my A term 25 or something like that, let's make it an easier number. Let's let that leading coefficient be 1. Then this B term, now A is 1, so 1 times C just becomes 2 times the square root of C. Okay, so if the leading coefficient is 1, that B term is even easier. Let's rewrite that for C. So let's do a little algebra, a little solving. If B equals 2 square root of C, then if I divide both sides by 2, I get that. And then if I square both sides, I get that term there. And this is what we're going to be using to help us create perfect square trinomials. Okay, we're going to see in a second as to why we wanted to know what is the form of that C. Because a lot of problems we're going to deal with, we're going to know the first term. We're actually going to know A is 1, so to make life easier. We're going to know that's 1, and we're going to know B. What we're going to look for is that C term, and we want that C term to force this thing to be that perfect square trinomial. So that's the mathematics behind what we're about to do. And you may have done this in your algebra classes when you did factoring, because that's what we're really trying to do here is factor. Factoring something you know to do, simple factoring like a problem like this. I can factor this to be, whoops, x and x, give me my x squared, okay? And the 6, I can do 2 times 3. Now notice this term is not a perfect square trinomial. 6 is not a perfect square, so it's not a perfect square trinomial. But if I do a positive 3 and a negative 2, that's my factor. Don't lose your equal signs. A lot of you keep losing your equal signs when you're doing equations. If you lose the equal sign, it's no longer an equation. So there's a basic factoring. And then you could go through and solve this. You could say, oh, so x equals 2 and x equals negative 3. But we're not interested in that right now, okay? Now that's an easy factoring. What happens when it's not so easy, though, okay? What happens if I can't factor it? If I were to try to factor this, I would say, okay, let's see, that's x and x. Only thing I know that makes 3 is 3 times 1. And positive, that means everything has to be positive, but that gives me 4x in the middle, and that's not what I want. So this does not work. So I need another way to do this. Now you could go use quadratic formula. That's if you wanted to solve for x. But remember, I don't care what x equals. I'm trying to change the form of this so we can connect it to what we're going to do later, okay? So let's change the form of this by doing what's called completing the square. I've written this down in just a few steps. And if you go through these steps every time, you'll be able to do this without any problem. So the very first thing we want to do is I want to get all my variable terms to one side. So all my variables on one side and all my constants to the other. Constant terms are terms without a variable. So I'm going to do that. I'm going to say, let's get x squared plus 6x and make it equal negative 3. I did that by subtracting 3 on both sides. So far, so good. Okay. Now, if there's a leading coefficient in front of that x, we need to factor that out. In this case, no problem. We'll look at an example later in which we'll have to factor that out. But right now, that's no problem. My leading coefficient is 1. For those that don't know, the leading coefficient is the first coefficient. That's why it's called the leading coefficient, because it's the one that's first. Okay? And when there's nothing written next to your x squared or next to a variable, we know that coefficient is 1. So far, so good. Next thing, I want to now complete the square. Now, this is where I'm going to take this thing here, this binomial, and create it so that it becomes a perfect square trinomial. I don't care about this over here right now. Okay, I'm trying to make this into a perfect square trinomial, which means it needs another term. I'm going to use my abilities with this b term to help me find what that constant is. So I'm going to use this b term to find what is known as the square the squared constant. Okay, that's what we're going to be finding. So the way I do that is I'm going to write out my problem again. So that's x squared plus 6x. I'm going to leave a little space. Okay, because I want to put that third term in the space. The way I get that third term, I'll call it c, will equal my b term, which is 6 over 2 squared. By the way, I just look at these 6. I don't care about the sign here because when you square it, it's going to be positive anyway. So it doesn't really matter what that sign is. So I ignore that. 6 over 2 is 3. 3 squared is 9. So there's my c term. So I'm going to take that c term and add it here. We're always adding. But wait a minute. Algebra told me if I add things to one side of the equation, I got to add to the other to keep it balanced. So I'm going to add to the other side to keep things balanced. So that's the completing the square part, finding the c term and then adding it to both sides. Because now this trinomial is a perfect square trinomial. We can see that if I go and factor this trinomial. So let's factor out this trinomial. If I go to factor this, let's do that in blue. Beep. If I go to factor this, that's x and x. 9, if I use 3 times 3 is 9, and positive 3 and positive 3 gives me the 6x in the middle. Oh, and this other side, well, negative 3 plus 9 is 6. Okay? But look at what you've got here. You now have a binomial times itself. So that's something times itself. Anytime you've got something times itself, you can rewrite it as x plus 3 squared. And there we go. We've now factored this using completing the square. Now, at this point in your algebra class, you might solve for x. You take the square root of both sides, you subtract 3 on both sides, and you get what x equals in 2 different ways. We're not interested in that, to be honest. I don't care what x is, okay? I want you to be able to get it into this form, okay? So let's do another example, step by step, and see how this works out again. All right, so let's do step 1, which is get all the variables to one side, numbers to the other side. So that's going to be x squared plus 10x equals negative 24. Now notice I went ahead and left a space. I left that space because I know I'm going to complete the square. As I was writing this, I realized there's a leading coefficient of 1, so I don't have to do any factoring out. So now I want to complete my square. So my c term will equal my b term is 16 divided by 2 squared. Okay, so my formula, remember, that is b over 2 squared. That's how we get that c term. 16 over 2 is 8. 8 squared is 64. So I'm going to add 64 to both sides. Don't forget to add it to both sides, okay? We now have completed the square. I now have my perfect square trinomial. So I'm going to factor this. X plus 8 and x plus 8. Okay, and I'm going to negative 24 plus 64 leaves me, I believe, 40. 4, 0, 2, yes. Okay, and now we've got our factored trinomial. Now you're going to get to the point where you're so good, you're going to be able to skip this step and go straight to here. In fact, with the rest of these, I'll probably do that because notice some little tricks here. Notice the number I'm using here. What's 16 divided by 2? 8. Or what's the square root of 64? 8. So it makes it very easy to see what's going on. The sign that's here will follow the sign of your b term. Okay, so that's the only time you got to worry about the sign. The sign of your b term matches the sign in your factoring. The sign of the b term of the trinomial is the same sign in the binomial. Okay? So try that. Why don't you try one on your own? Go for it. Okay, so here's how you should have done this problem. You should have gotten all your things into one side. I went ahead and did it, and here's your answer. So I moved my 11 to one side. I found my c term by doing 6 over 2 squared. So 6 over 2 is 3. 3 squared is 9. Add 9 to both sides. And now factor. My 3 comes from the square root of 9. My plus follows that sign there. 11 plus 9 is 20. Don't forget the squared up here. Okay, sometimes when people start taking the shortcuts, they forget the squared. So don't forget that part of it. Okay, excellent. So far, so good. If you had trouble with that, try doing it again. See if you can do a little better now. Let's try another example and see how this one is different. This time, I do have a leading coefficient. Okay, so I'm going to start off the same way. 2x squared minus 8x, and I'm going to move my 7 to the other side. That gives me 5. But this time, my leading coefficient is 2. So I need to factor out that 2. And I'm going to factor it out just on this side. I'm going to leave a little space. Okay. Now, at this point, I need to complete my square. Okay, so we've done step 1, get variables and constants on opposite sides. Step 2, factor out the leading coefficient. Step 3, complete the square. So my C term equals my B term. Now the B term is without the 2, so it's this 4. That's my B term. So I'm going to use 4 over 2 squared, which is 2 squared, which is 4. So I'm going to add 4 here. But on the other side, I'm not adding just 4. I'm adding 2 times 4. Okay, so what I'm doing is when I add to this side, I'm adding this term times what we factored out. Okay, because what I've really added in this is the 8. 2 times 4 is 8. So I got to make sure I add that to the other side as well. That's why we're doing that. Now everything else works out. Oops, let's change back to my blue. So 8 and 5 is 13. And now we factor this part here, which is just x minus, because my b term is negative, 2 square root of 4 is 2 squared. And there's our answer. Okay, so it's just one little teeny tiny extra step. Why don't you try one? Okay, try to factor this next problem. Go for it. Okay, so I took some steps and did them all at one time. I moved my 1 to the other side, and when I rewrote it, I left some space so I could put my C term in, and I factored out the 2. Remember, I'm just factoring the 2 out of this section here. So I sort of did it in all that in one step. You can do that if you want, but in your brain, you're doing it in 2 steps. Move the 5, then factor out the 2. If you want to take 2 steps, by all means do. Complete your square. 2 over 1 is 2. Whoops, 2 over 2. I wrote the wrong thing, but I was thinking the right thing. So 2 over 2 is 1, and 1 squared is 1. So I'm adding 1 here, and I'm adding 2 times 1 to the other side. So then we factor. Keep this 2. This factors as minus, because that's minus. Square root of 1 is 1. Don't forget your squared. 2 plus 1 is 3. And there we go. Okay. One more example that we might want to look at, or another type of example, maybe one more, maybe 2 more. I don't know. We'll see what we're doing. Let's take a look at this one. Notice the way this one's written. Things are a little off here. So I'm going to rewrite this one, and I'm going to rewrite this in a different way. I don't want my 2x squared over here. I want it on the other side. But the problem is, I don't want to put 2x squared on the other side because now it's negative. So I'm going to say, let me add 1 to both sides, and let me subtract 6x on both sides. Okay? And I'm going to rewrite this as 2x squared minus 6x equals 1. So I did switch the sides of that simply because I like having my variables on the left. It's normal. Does it matter if they're on the right? No, but we're used to having our variables on the left. Okay, I see some things going on here. I need to factor out my 2. And while I'm at it, I'm going to leave a little space for my square completion. Okay, now I get my C term. 3 over 2 squared. Ooh, 3 over 2. Don't give me a decimal. Decimals are useless. Squaring 3 over 2, way easier. 9 over 4. Because I don't know what 1.5 squared is. I can't do that in my head. But 9 over 4, I can do that. So I'm going to add 9 over 4 here. And I'm going to add 2 times 9 over 4 here, okay? I may take a little extra step on this one simply to get my arithmetic correct. So over here, I'm going to 2x minus, because my b term is negative, the square root of 9/4. Well, the square root of 9 is 3. The square root of 4 is 2. And remember, that's going to be squared. What about the other side? Well, that's actually 1 plus 9 over 2, okay? 2 times 9 is 18. 18 over 4 reduces to 9 over 2. And I have to add those together, so I need a common denominator. My common denominator, 1 becomes 2 over 2, so that becomes 11 over 2. So yes, you will have to deal with fractions some, okay? And stick with fractions. Decimals are not going to be useful in this, okay? As you move on, the decimals are going to make things way more complicated. So stick with fractions. Your turn to try one like that, okay? May have fractions, may not. Give it a shot, see how you do. Okay, so taking a look at this problem, all the same things happened, okay? I moved my 8 to this side, so that means I subtracted 8 on both sides. I moved my 1 to the other side, so that became plus 1. So the 4x I didn't want to move because it's already positive. I want to keep it positive. Always stay positive. So once I'm at this point, I got everything to one side to where I need them. Factor out the 4. Take the 4 out, that leaves an x squared and a 2x. Now I need to complete my square. So 2 over 2 squared is the 1. There's 1. And over here, I'm not adding 1. I'm adding 4 times 1, which is 4. So I took a little quick step there to get that. Now we just combine. Remember, middle term has to be negative. Square root of 1 is 1. Don't forget your squared. 4 plus 1 is 5. Easy as that. Okay? So again, this is just a lot of algebra, a way to factor. And to be honest, this method of factoring works for every trinomial that exists, okay? Fractions, anything like that. You can even use this with like square root things. It gets really crazy when you start to get in higher numbers. But this way of factoring works all the time. So if you're one of those students that struggles with factoring, this is a method you could use. It takes longer, but it works, okay? So that leaves you with some work to do, okay? As you go through the Google form, it's going to take it into steps, okay? What's your first step? What's your next step? What's your next step to help you get along through doing this? What's your C term? What's the factored form? What's the C term? What's the factored form? So pay attention to what's going on, okay? That's what we're working on today. Tomorrow or in our next lesson, we'll take this and combine it with circles. See you later.